Okay, hello, welcome to a regular Thursday open code review. Today, we are going to be reviewing, let me share my screen, P2328R1, join view should join all views of ranges. This is a fix for ranges. In order to understand why we're making the fix, it's kind of interesting to talk about the design of join view and show a little bit of history. So basically, what join view does is take a range of ranges of some element type and make it look like it's just mushed together as a range of all the elements. So if you had like a vector of ints, it would present it like just a range of ints with all of the elements of the individual ranges in order. So it's a pretty simple thing, and actually something useful comes up quite a bit when you're doing various rangey things. So the original design we had for this was that the join view would, when it was iterating over the outer range of things, it would have to take the range that the iterators dereference to and store that somewhere, so that while you were iterating over the join view, it could present you each of the elements of these inner ranges one at a time, right? Would cache an inner range somewhere. And in order to do that, of course, since we decided that views have to be copyable and movable and default constructible, it had to have the inner ranges themselves also had to be copyable and default constructible, right? So effectively, they had to be views. It only worked with ranges, or well, technically with views of things. And when we standardized join view, we made that design a little more general, right? We threw away the old range v3 design, and we said, we could do it like that, and we could also have a special case for when the outer iterators have references that are actual references to a range somewhere in memory, then we don't need to store a cache of that someplace in order to iterate over it. We can just iterate over it, and whenever we need a reference to that inner range, we can get a fresh one from our iterator from the outer range. So we didn't need to cache an inner range anyplace and copy it around as part of the view. And we could still do that and meet all the view requirements. And the problem that then arises from everybody is, I've got a vector of strings that I want to join into a string, and I can't do it because, strings are containers, not views. So if I have a vector of strings, well, actually vector of strings works because those would be L values stored somewhere in memory. They would work with the second design. But if I had a range that generates strings on the fly, say like a transformation from integers to strings, then I couldn't join those strings together because they're temporaries. They'd have to be stored somewhere. And we didn't want to store them within the join view with it, because doing so would make it an on view. So this was irritating to lots of people. And actually the ranges designers were aware of it while we were developing the ranges proposal. I had a fix in mind and even had sort of implemented it, but hadn't figured out how to specify it, and ran out of time. Like so many things with ranges, we ran out of time getting it finished up and merged into the IS, so it had to get fixed afterward. So this paper comes along, this from Tim Smong, who's been cleaning up a lot of the ranges mess in the last year, and applies pretty much exactly the fix that I had known about, right? He takes a cache. He basically realized that if we could cache a copy of something within the join view, but not copy that cache when we copy the join view object around itself, then the join view could still be copyable and movable and whatever, whether the other thing was technically copyable or viewable or owned elements or not. And we did this with a thing called a non-propagating cache, which is a cool idea. A non-propagating cache is basically like a stood optional, right? It holds some other object, except that when you copy or move non-propagating cache, it doesn't copy or move the contained thing at all, right? Copies result in the target being empty, moves result in the source and the target being empty. And that has great semantics when the cache is supposed to be caching the properties of some other object that sits next to this as another member of the same containing object. So to reload the cache, when you've moved the thing around that it was caching properties of, that those properties have probably changed and they need to be reloaded. So this reimplementation of join view is like, hey, okay, we'll use a non-propagating cache to store the internal ranges in so that they don't need to be moved or copied, and therefore we can join views of any kind of range, which is more general and satisfies that problem that people wanted to be fixed. So with that change in mind and the goals that we now understand exist, let's review this implementation of the paper from our contributor Misco, who has contributed so much of the ranges things over the years. I've already looked at this once a couple of weeks ago and asked for some changes. He's applied changes, and I reset my review, and we're going to try and look at it like it's from scratch, and I have never seen it before. So popping in, like always, the first thing we want to do is do the magic alt-click on the arrows here in the drop boxes for files, which smashes everything down to just headings so we can get an overview of what's being changed in the PR. There are product code changes here to the ranges header, which makes sense because that's where join view is implemented. X-utility, which is a common upper level header where things go that are shared by containers and algorithms. YViles core, which of course is the header that absolutely every single compile that touches the STL includes, which has things like feature test macros and various kinds of configuration in it. And of course, we have a test, right? Changes to the join view tests, which makes sense. If we're adding capability, hopefully we're adding tests to cover the new capabilities as well. So let's jump into product code here. And we'll get the wording of the proposal up as well, so we can compare. Well, not quite side by side because I can't get both things to show up side by side. There we go. Side by side. I'll zoom out a little bit on this and maybe in a little bit on this. Is that readable or too small? All right.
It's okay for me.
Hearing no complaints. We'll start on the wording here. The first thing is change being applied to the constraints on the join view class itself, right? Or if we're relaxing requirements here so we can join more views of things. And that is exactly what's happening, right? It's taking the old requirements that the template argument was a view type and that its reference type was an input range, right? Those still exist, right? This has to be a view of some other kind of range, but we're removing this latter pair of requirements, right? That either the thing that it viewed was itself a view, right? That the value type of the range V was also a view, or that it was a reference to something else that happened to be a range, right? An actual L value reference to another type of range that it was somewhere else in memory. So we're removing that requirement. And if we pop over here, oh, hold on, there's a lot of code up ahead of there. I'll come back to that. We can find, hopefully, the same change being made to join view somewhere. Yes, there's this change being applied to the implementation. The second clause has gone away. This first clause is still there, but without the parentheses that aren't necessary anymore. Now let's slide back up here and see if we can figure out what's going on with all the rest of this. Okay, this is an implementation of the non-propagating cache as an actual element within the library that we can use for other views. I'm surprised that the diff seems to think that it's a change to empty view, which it is. Okay, we'll get it scored away. Yeah, here we go. There's the first 3 lines of empty view. That's just diff weirdness. So let's look at the description of the non-propagating cache and the implementation thereof and make sure they agree. This says some types in this subclass are specified in terms of an exposition-only class template, non-propagating cache. Non-propagating cache of T behaves exactly like optional T with the following differences. It constrains its type parameter with is object v. The copy constructor doesn't do anything, right? Is equivalent to, here's a declaration of a context for a copy constructor with an empty body, right? The copy constructor does nothing. The move constructor has the effect of resetting the source of the move and doing nothing to the destination state, leaving it empty. Copy assignment operator is equivalent to if the right hand side object other, if other is not equal to this, if its address is not equal to this, it's a different object. If it's a different object, then we want to reset this. If it isn't, we leave this alone. So self copies have no effect. And similarly, not similarly, the move assignment operator is actually destroying. Right, we reset the states of both this object and the right-hand side of a move assignment, which is generally speaking the correct thing to do because we believe that there is other state alongside the non-propagating cache, right? And if that other state gets moved from some right-hand object to our left-hand object, then the cache on the right hand becomes invalid since the right-hand object has been moved from, and the cache in the target probably needs to be refreshed from the properties of the newly moved to object. So we reset those caches. And let's make sure we've got those things implemented correctly. Over here, template, non-propagating cache, this has a different kind of requirement, destructible object. If we scroll up, I don't know, destructible object is defined elsewhere. I think it's an X utility. Yeah. X utility defines the construct destructible object as is object v, which is close. It requires this to be an object type, but it doesn't require that we can destroy it. Require destructible. So the object type is start a review. You'll have to excuse my funny sound effects. I'm a big fan of funny sound effects.
Can we add such a constraint even though the standard E's only said is object v? Or is there something else implying that?
Optional. Std optional itself already requires that its type parameter to be destructible.
But
it applies CPP 17 destructible, which is not quite the same thing.
Okay. Do we end up permitting optionals of references? Is that a thing? I forget where we landed on that.
Optionals of references is an ongoing holy war in WG21. I suspect we will never have optionals of references. Unless you spell it pointer, right? People are very happy calling pointer an optional reference, but we'll probably never have specializations of optional int ref that are valid, for example, because of the ongoing argument about whether assignment should rebind the reference or assign through the reference. Since our mental model in WG21 of optional T is that it acts like a T with an additional state, then it gives credence to the it should assign through because that's what int refs do, right? It should act like a T. But yeah, people are very not happy with that semantic. So the war goes on, and we don't have optional references. Anyway, so yes, this non-propagating thing requires a destructible object type. All right, it's we have a nice comment telling us what it is. A simplified optional that resets on copies and moves. Okay, the default constructor, we set up here the default constructor. No, we didn't say anything about it. It should be just like the optional default constructor, right? In this case, we'd have a default constructor. Its constructs bring no exceptions, just this case we're still optional. It value initializes a member dummy. Let's go look at the data members below. Okay, we have two data members, an anonymous union containing a special type called a non-trivial dummy, and an actual tie. So the default constructor is initializing this one. And there's also a bool that tracks whether or not the value is the active member of this union, or the active alternative. Non-trivial dummy type, in case anybody is curious, is something we devised in our implementation of optional that does absolutely no initialization of any kind when it's value initialized. So we don't have to touch any of the bytes of the memory representation of this union when we initialize dummy. We used to just use a char, but then initializing it required us to zero that char in memory. So we made the change to make it a little bit more efficient, because every nanosecond counts when you're the standard library. All right, I'm happy with the default constructor. It works just like the optional one does. The destructor. Okay, this destructor is constexpr, because we're looking ahead to the constexpr optional and variant change in C++23, which this is supposed to be implemented in terms of, as if it is an optional that is all constexpr. So we have a constexpr destructor. It's explicitly no except, which is kind of strange for the STL. We don't conventionally declare destructors to be no except, since they are implicitly so. Don't know if that deserves a comment or not, but I thought about it and it looks weird. You don't typically misspell typically. Structures explicitly no except. Is there a reason to do so here? And this destructor does the right thing. It checks to see if the optional is engaged. If it's not engaged, there's nothing we need to do. If it is engaged, we need to destroy the contained value. Interesting. And we're activating the dummy. I don't see the purpose of activating this in the optional that's literally about to reach the end of its lifetime. At the end of our lifetime. Well, that seems like dead code. Okay, moving on. Looks like we have another prospective destructor that's used when tie is trivially destructible. That's simply defaulted, right? If tie is trivially destructible, we don't need this special dance to see if it's engaged and destroy it, because we don't need to destroy it at all. We can skip destruction in that case. So this prospective destructor will become the actual destructor if this constraint is satisfied, because it's more constrained than the other prospective destructor, which doesn't have any constraints at all. This one notably is not explicitly declared no except, and also not explicitly constexpr, but that's okay because it's default. Copy constructor. This copy constructor is fairly close to exactly what's specified for the copy constructor in the proposal, right? This one has an empty body and performs no initialization. Ours is initializing dummy. I assume that's necessary to satisfy compilers that haven't yet implemented all of the C++20 changes to constexpr to not require full initialization. But it's possible we could drop that. For people who aren't aware, const expr constructors before C++20 always had to initialize every member of the object, unless it was a union, in which case they had to initialize some member of the union, with the idea being that all the objects, all sub-objects were always fully initialized, and they couldn't just be defaulted. We relaxed that in C++20. We allowed default initialization in const expr, so you can have things like ints with indeterminate value in a constant expression, as long as you don't examine the indeterminate value before assigning it something determinate. Okay, moving on, copy constructor.
It's also quite possible that this was affected by recent compiler changes. I suspect Misco may have developed this against our earlier tool set, and we've just updated to 17.0, Preview 2, and Clang 12. So it could be that it was necessary for the old compilers, but can now be dropped.
Is this the same issue that we had in const expr string when we were trying to activate the SSO that we ran into?
That's an ever so slightly different issue.
Okay.
That one is with assignment to something with trivial construction. Assignment to a union member with trivial construction can magically start the lifetime of the object before performing the assignment in C++20.
Right.
That is the one that we know is bugged in at least Clang and MSVC. Neither one supports it well. But this one, the ability to leave things uninitialized is ever so slightly different.
Okay, thanks.
Okay, moving on, move constructor. Move constructor is equivalent to blah, blah, const expr declaration, reset the RHS. What do we do here? We, again, initialize dummy, which might not be necessary. We check if the RHS is engaged. If so, we destroy its member. We activate the dummy member, and we change its engaged. So this is basically inlining the implementation of reset. So can we avoid both this object Okay, otherwise this is correct. Well, even the things that I'm commenting on aren't actually incorrect. I'm just suggesting possible optimizations that might reduce the number of steps the const expr evaluator has to do when it's evaluating these things. Moving on to the copy assignment operator. Copyright assignment operator is equivalent to, it should reset only if the right-hand side is a different object. We check here. If the address of the right-hand side is the same as mine, do nothing. Otherwise, and this is, again, the implementation of reset in mind. I'm going to stop commenting. Issue appears here, and perhaps elsewhere. There we go. I try not to harp on the same issue over and over when I'm doing a code review for a contributor, right? I'll point out the first 3 or 4 occurrences of something, and then I'll say, all right, it looks like there's a lot of these. Why don't you audit for these? You know, our contributors are adults. They know how to write code in general, and they don't need you to point out every little thing. Okay, otherwise, this looks fine to me, right? That's the correct implementation of reset. Destroying any of the contained object, but only if it happens to be engaged, and unengaging after the destruction. Move assignment operator should reset both the target and the source. If they happen to be the same object, that's okay. The second reset will just do nothing. And And again, he's chosen to inline the implementation of reset. This looks just like the others. Destruction, construct the dummy out, initialize the dummy alternative, set engage defaults. Great. Okay, now we go on to other operators that came from std optional, right? Operator star returns a reference to the contained value, but requires the object to be engaged. I don't recall if we have no discard on std optional itself, but that's okay because this isn't really std optional, right? This is just something that needs to behave enough like std optional for the operations that we're going to use in our implementation. This type is never visible to a user, right? Users can't access any instance of this type ever. It's purely a specification tool as far as the standard is concerned. And our implementation tool just has to behave as if. We have a const and a non-const operator star. They are both identical. Perfectly good there. Okay, this is the exposition only in place deref member function. Has an additional template in place deref, which takes an I of some type. And the idea here is probably that I is an iterator into some range, and we want to take I and use it, take I, dereference it, and use it to initialize our contained value of type T. So this requires that initializing a T from star I is well formed for some invented variable T, which is going to be effectively enforced by this, right? Construct in place is basically going to do a placement new of the val object, which has type T from star I resulting to be difference in the iterator. And it will, this line will be ill-formed if that declaration is not well formed, and the compiler will diagnose it. So we've satisfied that mandates. The effects of this function, it calls reset. Right here again is the inline implementation of reset that we ought to recognize by now. Then initialize the contained value as if direct non-initializing an object of type T with the argument star I, which is exactly what construct in place does. So it initializes it. The post condition says star this contains a value. I guess contains a value is kind of words of power from the optional spec that means it should be engaged afterwards. So I'll allow it. There's a little awkwardness in the spec, but it's doing the right thing. Returns a reference to the new contained value. He has done that. In fact, here he's returned a reference to the new value, although it may or may not matter for our implementation, right? We don't necessarily need to do this if we don't need that reference. Throws any exception thrown by the initialization of the contained value and nothing else, which is how this works, yes. I guess it's important to know that construction of dummy can't throw exceptions. It has a no except constructor, and obviously destruction can't throw exceptions. So we're conforming here. Remarks: if an exception is thrown during the initialization, star this does not contain a value, and the previous value of any has been destroyed, right? Which makes sense. The reset happens before the construction, and we won't have set engaged true if this construct throws. So this non-propagating cache implementation meets the requirements of the standard for non-propagating cache. Now we have another specialization of it, and this is where things are getting weird. We have a specialization for when tie is trivially trivially destructible and default constructible, which is kind of strange. It wants to store a tie directly and not keep track of whether it's engaged. We're attempting to save state here. Not sure how conforming this is. Apparently Tim's also not sure how conforming this is. I don't think anything in the wording permits calling a default constructor that can have arbitrary side effects. I agree that this doesn't seem to conform. Is necessary if this class is default constructed. But again, don't see how the standard allows that. Anyway, I suspect we're going to just end up striking this specialization. But let's double check that everything's correct here. Otherwise, the copy constructor doesn't do anything special, and there's no except if the default construction of the contained object is no throw. That makes sense. Move constructor should probably be the same, and it is, right? It does nothing, and it's no throw if the default constructor is no throw. Copy assignment does nothing, which is bizarre. This doesn't reset the RHS. Is copy assignment supposed to reset the RHS? If it's a different object, yes. All right, I'm mildly concerned about that. Let's go ahead and comment. If I can figure out how to scroll back to the left. There we go. These potentially valid the probably do something different here. And move has the same issue. Ditto leaves RHS in a weird state. All right, these reference operators are the same. In place to ref doesn't do the reset. It contains a value even if the construction fails. It's not clear what that value might be, since we're literally constructing another val on top of this val. Here again, resulting state unclear. Right, presumably, whatever value was there before may have been partially corrupted by the construction process that was aborted. Yeah, this is very scary in general. I would like to get rid of this partial specialization. Okay, moving on. I think we can finally move on. Done looking at non-propagating cache. Let's focus on just the changes to join view. Copy constructible object. Oh, here we're replacing use of copy constructible and is object with copy constructible object that I think already existed previously. I remember declaring that helper concept Yeah, that helper concept already existed up here that was used to constrain something else in the implementation. He's just making it more general. That's a good change. Especially to let us get rid of some manual claim format overriding here in the declaration of single view. All right, there's the join view declaration that we already looked at with the change, with this change, so we're ready to move on. The inner member is being changed from something, an intermediate condition, basically, that's a different than the start condition of this paper, because we've already started implementing other ranges changes. Right, this was a result of the paper that allowed views to not necessarily be default constructible. We had this particular box that does weird things, so we're replacing it now with the non-propagating cache of remove CVT of inner range, which hopefully is the same thing as range reference T of the parameter. And yeah, the definition of inner range is up here. This is in light gray, so you may not be able to see it all highlighted, but inner range is an alias for range reference T of the parameter type. Like the parameter's range reference type is, sorry, since the parameter is a range reference T of the parameter is the type you get when you dereference one of its iterators. The decal type of one of its iterators, dereferences, which we know must be a range since this is joint view. But anyway, that change is correctly reflected here. It's become a non-propagating cache. Moving down, this is repeating the change to the constraints in the redeclaration of join view that appears in the declaration of its nested type. Wow, it's painful to say. Join view iterator. We don't have that problem in our implementation because we declare the nested types directly in the body. So we don't have to repeat that many constraints. The exposition only mirror satisfy is being changed. That lives right here. Context per void satisfy. We implement that. We reflect that directly in our implementation. And it's being changed to for loop. Right, for outers not equal to ranges end of parent base is spelled parent range in our implementation. And it looks like we're caching that in value instead of repeatedly calling it every time around the loop, and that's just fine. Plus, the actual change here is to have this auto ref become an auto ref, which we did. Auto ref temp becomes auto ref temp because update inner with the star removed on outer might do something different. And this is not passing outer at all to update inner. But that's okay, because outer is a member of the class, and our update inner is not a lambda, it's an actual member function. Ta-da! So the change to update inner hopefully is similar. This returns star its argument. And the argument was outer. Right. Our outer is a member variable, so we're returning star outer when deref is GL value. This is the same condition. And the corresponding condition, this returns parent inner dot in place deref x, right? Parent arrow inner dot in place deref. So we did need to return the correct type from in place deref because we're using it here in the implementation, right? It's being returned from update inner. These agree. These agree. Those are the only two changes here, right? Yeah. The addition of a ref and the removal of a star. a white space change for alignment. What else do we have here? Addition of a star for implementation of operator plus plus. Let's go dig this out and see if we can figure out why he didn't make a change for that. Here, pre-increment. Let inner range be star outer if ref is GL value is true. All right, we call ref is GL value, deref is GL value. So if it is true, let inner range be star outer, and it's equivalent to auto ref inner range equals inner range in kebab case. If plus plus inner equals the end of inner range. All right, so we are just propagating star outer down through here where the uses down through this single use of inner range, right? Star outer appears there. So that agrees. Plus plus outer invoke satisfy. So in the other case, right, when ref GO value is false, the other case is the one where that actually has a difference. Then this is the change. Auto ref inner range is now star parent arrow inner. So the star was already there, and that's why we didn't need to add it. The standard had to add it because, again, its initial state was a little different than our initial state. We added this star when we made the change to use default a box to store inner. There, the original state that was in default box. We added the star then, so we didn't need to add the star after changing it to non-propagating cache. Which, anyway, default box is just a slightly different optional like thing. Like I said, this is kind of confusing because there were two simultaneous changes made to this join view by different proposals. So I believe this to be correct. We've ended up on the right end point when we merged the two together. And having gotten there, we're at the end of the proposal here. So we've covered, I think, all the product code changes. Yay. We had a couple of comments there. Let's look on down here. In X utility, like I said, we were adding destructible object to factor out this notion incrementable traits. What? Why are we adding this requirement here to the specialization of incrementable traits for pointer types that they must point at a destructible object type? This destructible destruction.
I would imagine it was just because, right, wasn't destructible object originally defined to be literally just is object? And you're asking for them to also require destructible? Might just be trying to simplify things, I guess.
Oh, it might have been confusion. Yes.
I'm just trying to burn more cling format on-offs, I think.
Oh, yeah, that's what happened. That's what happened. I meant, hey, this specific occurrence of you constraining something with is object, non-propagating cache, right? He was just constraining non-propagating cache with is object. Mm-hmm. And I pointed out that it needed to be a destructible object type here.
Yeah.
You should change this to destructible object. And he appears to have grabbed everything that's template requires is object v and changed them to destructible object. Oops. This is what I get for being unclear. Okay. Well, I'm glad we didn't miss any more in ranges, but we'll have to go through. Aha. That helps. Oh, there we go. Imatsuhara points out. String change for non. All constraints. Also require destructible in the constraint. There's restore. Yep. Also occurs on 403 and 670. I don't know, just simply thought I can just specify all of them. On 403 and 670. Okay, restore. That takes care of the product code changes. X utility as well. Okay, great. We have a touch in YVal's core, basically just specifying that this proposal was implemented. Make sure that the proposal number is right. This is the Stefan spelling of the title. I think join view should join all ranges.
It's missing some words though.
Oh, but Casey changed it. That's right. Did I change this one? Did I overrule you? Apparently I overruled you. All right, let's. Full paper title here. Of should be capitalized, sorry. Anyway, this makes more sense with code font, right? If you realize that join view and range are in code font, this mirrors exactly the result of the change, right? That before this, join view could join views of views and views of some kinds of ranges, but after the change, join view joins all views of ranges. So. I found the wording significant enough that I think we should have the full wording. Okay, test code. There shouldn't be a whole lot here. We've changed. All right, we have a can test constraint in the code here that is applied to our ranges test code has basically a combinatorial explosion of different range types that it throws at the various view adapters and then make sure that they adapt them correctly. For join view, since it had such a weird requirement before, the easiest way to do it was not to change the test code to only give it the right kinds of ranges, but to have this part of the test take all the ranges and then filter out just the ones that actually work with join view. So that's what's being changed here, right? This is saying it's removing this additional requirement that looked a lot like the additional requirement on join view itself that's being removed. Saying we no longer care about this particular property, right? All other things can be adapted by join view. Let's go ahead and test those as well. So that's a righteous change. We're hopefully admitting more types into the test. And it looks like we're adding an additional test case here. We've got a constexpr array of string views. I'm wondering why this is an array of string views instead of an array of strings. I guess array of strings is going to be joinable as well. A function that returns a vector of a particular number of zeros. Oh no, a vector containing only this value plus 1, sorry. This is going to call the initializer list constructor. And a function toString that returns a string constructed from the member of this array at index val. All right, that's kind of weird too. I assume we're going to use, we're probably going to use a transform. I'm probably going to take an iota view and transform this array into an array of PR value strings. Let's go see. Specific test case for P2328, range of PR value array. Result lambda function 2 array. Okay, we assert that our range is equal. We're going to take an iota view, 0, 5. This is going to be just the integers 0, 1, 2, 3, and 4. And we're going to transform it through the 2 array function, which will result in arrays of single integers 1, 2, 3, 4, and 5, and then pump that through view join. So joining together these arrays of single integers should give us one array of all the integers 1 through 5, just like the content of results. And that's what we're asserting, that the result in fact is equal to this view composition. And we also have a static assert. Make sure it works at compile time as well.
Do you think it's called 2RE on purpose, or is that a typo on the lambda?
I have no idea. There was a global, oh no, these were 2 vector and 2 string. We'll ask. You. Know if this is not named to array for a particular reason.
Perhaps it was originally supposed to be to Arya, but she's hiding out from the Lannisters.
Ah.
You're gonna cite me being like nitpicky, but you're not gonna cite Stefan being snarky.
A girl has but to name a bug, and that bug will be eradicated. Game of Thrones jokes. We can't make Game of Thrones jokes due to the tragic way that show ended. Okay, sorry, moving on. Test case number 2. range of PR value vector using global function. Okay, we see the same result, 1, 2, 3, 4, 5. We're again taking views iota 0, 5, transforming it through 2-vector, which is the global thing that returns a vector with a single element equal to its argument plus 1. All right, so basically this is the same thing, except it ends up joining vectors of single integers instead of arrays of single integers. And this apparently runs across a construct per issue in their released MSVC compiler that doesn't exist with the internal MSVC compiler.
Do we know what bug number that is? Is that something that got fixed in 17.0 preview 2? It would be nice to have confirmation.
I have no idea because it's not annotated with a bug number.
yeah, well, transition at a minimum, because that's the reminder for us to search when something gets fixed. We try to be real disciplined about that because looking through other code bases, like say the compiler code base, you'll see to do, temporary hack, and it's annotated like, 1998. And clearly nobody ever went back and removed the hack.
Also on 540, 547, 555. What I said, right? Sure it is. All right, commented. We'll make sure that the static assert is the same as the runtime assert. It is. A range of PR value vectors using lambda. So this is exactly the same argument, except we're transforming with a lambda. We're not here to test views transform. This seems kind of redundant to me, but I don't know if it's worth complaining about. Yeah, the runtime and compile time tests are in fact the same. Range of PR value string using a global function. And for whatever reason, we've decided to change from views iota 0.5 to views iota 0u 5u. We want unsigned integers now. I guess because toString takes size t. Sure, why not? We transform them through toString, which takes each integer 0, 4 through 4 and uses them to index into this array. 0, 1, 2, 3, 4. All right. So the result should be hello world. Unsurprisingly. And make sure the result is expected. And expected is supposedly defined back here. Construct per string view expected. Compile time and runtime are the same. Range of pure value strings using a lambda. I think this is exactly the same body. String pure value input of I. String of pure value input of I. Yeah, it's exactly the same body, but as a lambda instead of a global function. And otherwise, view composition is the same. Compile time and runtime are the same. Oh, and this is removing. I'm gonna guess this is the bug. Call me crazy. I'll guess that this VSO 934264 is the bug that we're trying to avoid here with each of these individual constructs per test.
That bug is still active, so it is unclear whether it has actually been fixed internally. The main hazard with having new code that's guarded by MSVC internal testing is that the moment we try to port it internally, if it doesn't actually succeed,
If it doesn't
the test will
actually
fail.
internally work, we have fun to fix it.
Yeah, it looks like we reported it to the compiler around March. Or no, it might have been reported earlier, but you commented in March that it's now affecting tests for the implementation of some ranges in the STL.
I know
there's been no
Misco
update.
sometimes sticks MSV internal testing on branches before they get merged, so he can point the compiler deads at them and say, make this test pass.
That makes sense.
So that might be what's going on. Yeah. But I'll point out that that bug hasn't been fixed. Fixed internally.
With a slight possibility that it has indeed been fixed, but the bug in the database has not yet reflected that. Maybe 10% chance of that.
Oh wait, it has been fixed?
No, I'm saying there's a possibility that the bug is physically fixed, but because of a duplicate getting resolved and the database here, we just missed that one. It's possible. So I mean, I would maybe weaken to doesn't appear to have been fixed internally or something like that.
There. I'll let him explain instead of writing out multiple kinds of guesses. Okay, that's everything. We've looked at the tests. We've looked at the product. I've pontificated on the design of JoinView. Do you have any questions here in the chat? I haven't looked at all.
There was a
Isn't iterators are ranges typical for iterator sentinel pairs? No, Charlie, it is not. There are specific kinds of iterators we have in the standard library where the iterator itself is a range. You can call begin and end on the iterator and get a range. Path iterators are one of them because path iterators, sorry, no, it's the value type of path. The value type of path is a range of path, which is horribly confusing and causes all sorts of problems. But directory iterators are also kind of ranges. You can call begin and end on them and iterate over the same thing that the directory iterator would iterate over. Anyhow, moving on. Mia helpfully posting links on Vue. IS is an acronym for International Standard. Did I say IS? Oh, no.
Yeah, you did early on. I just wanted to helpfully expand for people who are unfamiliar with the terminology.
I've been hanging out with core people too much. I was at UWG this morning. It's not my fault. The alt-click trick. Yeah, we say the alt-click trick at the beginning of every one we use it because it's so awesome. Shouty banners. Well, did you see shouty banners in here?
I thought I did.
Well, they knew there are old shouty banners that are being touched, aren't there?
There's the non-propagating, which is a new class, right?
All right, I'll ask him. Should we ask him to strike the shouty banner? This is going to interfere with the shouty banner removal anyway. If you look at it. No, because this is new.
Well, this is a new one, yeah.
Like this new shouty banner. We're getting rid of them.
Yeah, I'll try to get that merged in the batch after this one. So hopefully sometime next week. That way we don't need to keep remembering to update in-flight PRs.
All right, let's do a quick scan for other new shoddy banners. I'm sure there's one on the specialization. Oh. This is pre-existing, even though it's green. That's kind of confusing. Yeah, that's it. Okay. Billy commented on the incredible quality of GitHub's diff tool. Cogent throughput. Debugging consequences of using a class type for that aren't worth it. So I'll keep, leave that's a pointer parade. I have no idea what you're talking about, Billy.
Charlie's comment about optional tref.
Oh,
and,
okay.
And Bill's and my dislike of optional tref as a concept.
Optional tref is a pointer.
Yes, exactly.
Is dummy okay with polycheck? It's been shipping for a while, and I know we've polychecked all the code. I think that postdated the original. Yeah, dummy was in the initial implementation of optional, so polycheck would have caught it if it didn't like it. I think dummy is okay because it generally refers to like a test dummy, something that's not real. It shouldn't be offensive to anyone because
I figured it was just, I noticed it was worth asking.
Blah, blah, blah. It's such a rebindable non-null pointer type, even implementable in standard C++ with a class type. You'd have to check for null in the constructor, which is a different thing than making it actually structurally non-null. Yeah, weird things happen. And we have cows in chat. The best are moo to do. Oh, there are compiler comments. They don't use to do in the compiler. They have M00 to do's that were originally put in there. I can't remember the name of the dev, and I probably shouldn't be naming names anyway, but yeah, there was a dev that used to use MOO to do for all his to do's, and Cameron's commenting that it's funny that they make the compiler code sound like there's a cow. Billy asking if we need to define core people. Yeah, by core people, I meant members of the core language working group. I hang around with them sometimes, and when I do, I pick up their linguistic patterns and end up saying things like IS that only make sense to people in core.
You need to define things all the way down.
Yeah. Got it. Thank you so much, Billy, for the helpful comment.
Yeah, I'm sure.
All right, I think that's it then. So let's call it a day.
Okay,
Thank you, everyone,
cool.
for coming. Hope you enjoyed the review.
Thanks for reviewing.
Thanks.